PathPilot QuickTips. Today I'm going to go over physically setting up a ZA6 robot next to an 1100MX, and after that we'll cover networking the two of them so the robot can send commands and get status feedback from the CNC machine. Okay, so what we have here is a ZA6 and we've got it mounted to a steel table. We sell a table for our robot. If you have that, or if you have your own table, as long as it's stiff, sturdy, and relatively puts the robot at the same height as the machine's table, then you've got the first step covered. Next, though, we're going to want to get the robot roughly centered within the opening of the side window of the machine. So we can see here that the rotational base joint, joint 1 of the robot, is roughly centered within the enclosure's side window opening. The next thing we need to think about is how close the robot is to the machine tool. So, I mean, obviously I can push this thing, right up next to it, or we can have it a little bit further away. What we want here is we'd like the robot to be able to reach as far into the enclosure as possible, but we have to balance that with having the tooling clearing here as we rotate joint 1 into position. But if you need to maximize the reach in, you can actually bias the joint 1 axis a little towards the back of the enclosure. What that does is it allows us the maximum clearance between the front edge of the window opening and the robot's tooling as it rotates to access the rest of the table. We can certainly change the robot's trajectory to make that work better. This is slightly better, but if you see, this clearance is going to determine how close I can place this robot. And the closer I place it, the more I have to worry about that collision. The other thing to check is to make sure that when this joint, joint 2, has the robot's arm straight up and down, that you're not much above the top of the window opening. And that'll help prevent a collision between the top of this joint and the top of the window. So lastly, I like just to keep things aligned, right? And I'd like to have the robot's y-axis aligned with the table's y-axis. So what we've ended up with here is a robot roughly positioned, biased towards the rear of the enclosure window opening, and with the table nudged pretty close up next to the enclosure. Clearly, how far the robot needs to reach in here really depends on where you've set up your work. In this case, what I've done is I've jogged the machine all the way over to the extent of travel in the X direction to give the robot as much work envelope as possible. And you can see that even with the table really up close, we'd have a hard time reaching to the left half of the table. So it's really a balance here on the robot side between how far the robot can reach in, how close you want it to the enclosure, and where your work is located on the table. The robot's got to be able to come in and reach the pickup position, so it's got to be close enough that it can reach the poses that we want. You'll notice that this table is on casters. When we get this into position, what we'll want to do is jack it up off of the casters with the leveling feet. Doesn't necessarily have to be level, but what we don't want is the table walking around. And in fact, the robot is capable of such high accelerations and velocities that if you really want to run it to its maximum performance capabilities, you'll want to anchor it to the floor. And now the last thing we'll do is we'll go ahead and run these feet down and lift the table slightly up off the ground. All right, that wraps up the physical placement of the robot. Now let's talk a little bit about networking the robot and the mill so the robot can send commands and receive status updates from the mill. So depending on your facility, you may have a local area network already in place. And if you do, you'll just want to make a connection via Ethernet between your mill controller and your local area network, as well as a connection between your robot controller and your local area network. And that's just like plugging in any other regular computer. On the robot computer, you'll see we have two ports, two LAN ports. Port number 1 is for the robot's EtherCAT network. Port number 2 is for a regular internet connection or a connection to your local area network. On the mill, it's slightly different. There's only one Ethernet jack, and that's required to connect to the mill's electronics. So what we have here is a USB to Ethernet dongle. I'll have the part number down in the description here. And you'll use this to connect via Ethernet to your local area network. If you don't have a facility that's networked, this is a very inexpensive network switch. Plenty of manufacturers make these, and all you really need to do is have the two of these, this switch with both the robot and the mill connected to the port. So if your facility does not already have a number of open local area network ports, it's relatively easy to pick up one of these switches. They're inexpensive, a number of people make them, and what you can do here is create a small network locally in your garage or your shop and plug in both the mill and the robot to one of the ports on this. And I will say, if you do have network connection via Ethernet, it's extraordinarily handy. It allows you to use PathPilot Hub with both machines for file transfer. It allows you to easily update the software from both machines over the internet. Highly recommended to get your machine on the network. Last thing is we get asked regularly, what about Wi-Fi? Can I use Wi-Fi to connect the robot to the machine tool? And the answer is yes, but I really don't recommend it. You want something reliable, and Wi-Fi has all sorts of issues with connectivity and reliability. It's okay for downloading a software update because we use checksums to verify the accuracy of the payload, but with something like real-time communication between two industrial tools, you don't want to do it over Wi-Fi. Much better to hardwire it. So once we get both machines connected to the network, if you start them up and you go over to the settings screen on the robot, what we'll see here is a column of discovered machines. So fair warning, if you have multiple PathPilot controlled machines on your local area network, all of them are going to show up here. For this setup, for this video, we only have one. It says PathPilot on Tormach PCNC-8.local. I'm going to highlight it. I'm going to click Add, and it allows me to name it. I'll call it 1100 MX. I'll click OK, and you'll see that it comes on, and then within a few seconds, that little green circle turns lit. And we can go ahead and easily test this just by having the robot issue a command to the mill. So in our robot programming language, so if you go to the robot documentation tab, we see here in the documentation here, there's a whole PathPilot remote section. And these are the commands that are currently available, and we add to these all the time. But we can do a cycle start, and you'll notice in the command, you can either just issue the command, in which case it will take the default instance that it's connected to. Because we only have one machine connected, that'll work. If you have multiple machines connected, you can use a string identifier. So I called this mill 1100MX in our documentation. If we wanted to be pedantic about it, we could include that string, the 1100MX. So I'm going to go ahead and just issue an MDI command to our CNC machine, and we'll see if it follows that MDI command. And that'll prove to us that this is working. So I'm going to go over to our robot program here. I'm just going to issue an MDI command. PathPilot MDI, and then I'm going to say M9. Let's check the documentation. That would be PathPilot MDI and then the string M9. So let's give it a shot, and this should turn the coolant on. Actually, it should turn the coolant off, sorry. PathPilot MDI M8 for the coolant on. And we hear the coolant pump, and we see the coolant coming on over there. So easy enough then to turn the coolant pump off. We know that the connection has been made. So today we talked about physically setting up the robot next to the CNC machine, and then we talked about how to network the robot and the CNC machine so that the robot can send commands like cycle start or MDI commands and also receive status updates from the mill. Thank you so much for watching.